The stack is what is known as a LIFO data structure, last in, first out. That is, the last thing you put into it is the first thing you get out of it. You add things to the stack with a push instruction, and you retrieve things from the stack with a pop instruction. Simply put, the stack is a block of memory and a pointer onto the top of that block. The pointer is the address held in the ESP register. This is a diagram of the stack. A push instruction does two things. It first subtracts 4 from the stack pointer register, then it copies data onto the new blank space at the top of the stack. The pop instruction does just the opposite. It copies 4 bytes from the top of the stack, then shifts the pointer to the next 4-byte block on the stack. You've seen the examples and the use of push and pop instructions to manage the stack. Stack symmetry is very important. Every time something is pushed onto the stack, it must be popped off. If you go off and leave something pushed on the stack is corrupted. The next instruction that pops something off the stack will get garbage, and if you're lucky, your program will crash. If you're not so lucky, your program will just go awry and do something mean. There is more than one push instruction. Some push instructions push several items onto the stack at once, but every push instruction has a corresponding pop instruction, and you should use that to keep the stack cleared off in the right way. There are 2 stack instructions that are combined with branch instructions to facilitate function calls. You've seen call used in the previous examples to call functions. These 2 lines of code are an example of a function call. The call instruction first pushes the address of the MOV instruction on the stack, then it jumps to the address specified by the function name. And that's all it does. The counterpart to call is the return instruction. It sits at the end of the function and performs a very simple operation. It pops the address off the top of the stack and branches to it. So you can see how stack maintenance inside the function is important. The return address must be on top of the stack when this opcode executes. As you've seen in the examples, arguments to functions are pushed onto the stack before the function is called, and after the function returns, the arguments are popped off the stack. It's sometimes done that way on other CPUs, but there is a reason why it's done this way for this particular CPU family. The arguments are below the return address on the stack, so to remove the arguments and use the return opcode, it would be necessary to pop the return address off the stack, save it, then remove the arguments from the stack, and push the return address back onto the stack. Then return could be used. Another problem is that a function can be written to allow a variable number of parameters, and if the function were to be responsible for clearing the stack and it got the number of arguments wrong, the program would simply crash. The return address is the last thing pushed onto the stack, so it's always at the location pointed to by the ESP register. The last argument in this example, the second argument, is on the stack immediately below the return address, so it's at ESP plus 4. The first argument is the one on the bottom of the stack. In this example, there are 2 arguments, so the first one is at ESP plus 8. There are other calling conventions, so watch out if you're mixing languages and/or systems. For example, the Pascal calling convention is to push the arguments on the stack in the opposite order. That way, the argument directly beneath the return address is the first one, not the last one. Another convention, known as syscall, works the same way as C, except the count of the number of arguments pushed onto the stack is stored in the AL register. The fast call convention passes the leftmost argument by storing it in the EAX register. The next argument is stored in the EDX register. The next is stored in ECX, and then the rest are pushed onto the stack. This is the calling convention of the Borland Delphi. There are other calling conventions, and there are variations on these. If you're going to link with modules from another compiler, you can do it, but check the calling convention first to make certain that your code is compatible.